Let's discuss the necessity and effect of software configuration management. The need for software configuration management can be explained by looking at the signs that the CM is not performed at all. Organizational signs that cannot be managed by software configuration management include many problems, such as late project delivery, poor quality of developed software, omissions of software changes, unauthorized software changes, bugs after release, and high level of rework. Let's look at these signs in more detail with the components of configuration management, such as version control, change management, build and release management. First, version control refers to the storage and management of files, programs, and products that are changing during the life cycle of a product. Let's look at the organization's symptoms if there is no version control. We do not know exactly which version affected by reported bug. More than one developer cannot work on the same file at the same time. They have multiple copies of the same file, module, and multiple versions of the program. It's hard to compare the differences between two or more versions. Knowing files, modules, and programs have changed, but we do not know exactly what the changes are. Second, change management refers to planning, implementing, monitoring, controlling, recording, and reporting software changes. The following symptoms may occur if there is no such change management. We are not sure who changed files, programs, or products. We cannot tell when a developer has finished tasks. We cannot track which files, programs, and products affected and implemented by reported bugs. There is also no statistical data to determine if the product has stabilized. Finally, scheduling and assigning tasks to add new features or parts are difficult. Third, build and release management refers to auditing and managing changes implemented in releases or builds of software products. If there is no such build and release management, the following symptoms will occur. We cannot tell which version of the product the customer has. We do not know which changes were implemented in the product and released or built. Also, rollback to a version that the product worked reliably does not happen immediately. Finally, it is difficult to rebuild a particular version. Therefore, the effects that can be achieved by adopting the software configuration management system are as follows. The transparency and integrity of the development process is guaranteed. Development documentation can be systematically managed, and changes to the source code can be monitored and controlled. Confusion caused by source code is minimized. It is easy to do concurrent development of multiple versions. Consistency of source code, development documentation, and programs are ensured. Now, let's look at the functions of software configuration management. Software configuration management must first identify each part of the system. It is the tasks of classifying each configuration item and organizing and assigning the numbers to items in the management list. This process is called configuration identification. Once you have identified configuration items, next step is to control the configuration items which change over time. Then, a configuration audit is carried out through objectively verifying and validating whether the change of the configuration item has been made according to the requirements defined at the beginning. There should also be a configuration status accounting process to record and report document changes or status changes of each configuration item. Software configuration management is an important factor for quality assurance, and let's talk the functions more specifically. Configuration identification activities include assigning names and control numbers to the configuration management subjects and separating them into hierarchies to facilitate modification and tracking. Configuration control is the process of reviewing the change requests of the identified configuration items and adjusting them to implement in the current baseline. It is the task of managing the different versions of the configuration items generated by the software processes and combining them with specific procedures and tools. Configuration audit activities are activities that are formally approved through verification, validation, and inspection to assess the integrity of the baseline. Finally, it is the configuration status accounting. It is the task of recording and managing the results of the identification, control, and audit of the configuration and creating reports. Let's look at how the configuration management works in the software lifecycle. First, when development begins, plan configuration management and define organizations such as configuration managers and configuration control board. During configuration management planning, the configuration manager schedules the configuration management activities and estimates configuration management resources, then creates the configuration management plan and obtains approval by the configuration control board. Next, it defines the configuration items and baseline. Then it controls the configuration through baseline management. When the baseline changes, change requests and changes to existing configuration are controlled by the formal change process, and regularly check the status of these configuration and shares them with relevant stakeholders. It also verifies and validates the configuration through configuration audit to ensure integrity. The configuration manager identifies the configuration targets and items, considering the likelihood of change, need for version control, and whether it is a shared resource. And he or she assign the configuration item identifier to the identified configuration item. The purpose of configuration identification is to define the organizational structure of the document as a clear and predictable appearance. It also provides an easy-to-modify method or makes it easy to track when changes occur, and ensure that changes to facilitate control are combined with who, when, what, why, and how information to keep track of future changes. Click the button provided to view the software configuration items for software configuration management. Let's look at an example of selecting configuration management items from the embedded software configuration management system. The software divides the system into functional unit segments. The segment can be decomposed as a software configuration item, CSCI. CSCI as a software component, CSC, CSC as other CSC, or a software unit module, CSU. This hierarchical decomposition is generally suitable for functional decomposition. On the other hand, in the process of system modeling, you also have to consider the analysis and design of the network decomposition, such as object model. The developer defines a list of software configuration items based on system decomposition structures, design requirements, management structures, and available resources. These CSCI structures should be reflected in the contractor's software development plan and configuration management plan. We should also be very careful when selecting the number of configuration items. If you define too many configuration items, the effort to manage the software configuration items will be causing schedule delays or increasing development costs. On the other hand, if the configuration items are too small, there will be an increase in operational defects due to reduced program visibility to software development, and software control points will be reduced to affect the quality. As software is invisible, it is difficult to manage, so the software can control the configuration by the work products created during the development process. Configuration change control activities include configuration baseline management, configuration control board, and software change request. Configuration control reviews and accepts software configuration change suggestions so that they can be reflected in the current software baseline. In addition, configuration control performs change request management, change control, operations control for configuration management organizations, and configuration control and support for development and subcontracting organizations. You build a configuration library system for registration and management of configuration items so that configuration items can be changed according to the check-in, check-out procedure when a configuration item change request is made. The procedure for controlling the configuration takes 5 steps. First, a change request is initiated by a team member or project customer. This change request is analyzed in terms of cost, time, and change definitions, and schedule the change impacts. Then each proposed change request is distributed to team members. After the appropriateness of the changed configuration item is evaluated, the rejected change is recorded for future reference, and the results of the evaluation of change requests are fed back to software developers and customers. This time, let's discuss the configuration baseline, that is, the baseline setting. It sets the configuration baseline by the point when the configuration management is needed, and determines the configuration items that need to be managed by each configuration baseline. The configuration manager defines the physical repository, form, location, access control, and backup and recovery procedures to the configuration library system. Baseline is a specially reviewed and agreed upon specification or product that helps you properly control software changes during software development. So let's talk the types of configuration baseline in more detail. Types of configuration baselines include functional baseline, allocation baseline, design baseline, test baseline, product baseline, and operational baseline. A functional baseline is a baseline that is established at the time of review of a user's requirement analysis or specification. The distribution baseline is established at the time for reviewing this document or a high-level design specification that defines how the user's required functions are allocated between hardware and software. The design baseline is established at the time of review or design specification for programming. The test baseline is established at the time of the test planning or evaluation of the deliverables, including source codes, executable codes, and test cases to evaluate the functionalities and performance metrics of software. The product baseline is established at a time of assuring the quality or the product completely developed as single system. The operational baseline is established at the time of evaluating the quality of the software installed or operating in the user environment in terms of user perspective. Let's look at the organization of the Configuration Control Board to manage and control the configuration of software products. The Configuration Control Board consists of Configuration Manager, Configuration Library System Administrator, Project Manager, and Designer. The Configuration Control Board performs the functions of identifying the configuration items, setting the configuration baseline, and decision-making of configuration control to manage and control the configuration of the software product. The following is an example of organizing the Configuration Control Board in the Embedded Software Configuration Management System. The Configuration Control Board is responsible for monitoring and approving changes to the system. The Software Configuration Control Board conducts review and evaluation of software technology change proposals, decision-making on processing procedures, and software documentation. Software documentation, change requests, and change suggestions are initially sent to the Software Configuration Control Board. Any technical changes that are delegated or not determined by the CCB are determined by the SWCCB. At this time, priority should be given to the urgency of the software technology change suggestion. But if the change is group or block unit, you must decide them together. And the SWCCB runs concurrently between acquirer and contractor with the CCB. Now let's talk about the software configuration audit. A configuration audit is an activity that verifies whether the developed software configuration items match the software configuration requirements, and they meet the requirements of the configuration baseline documents developed before the development phase. This is done through testing, audits, and technical reviews activities throughout the software lifecycle. Configuration audit activities should be performed with software development activities to periodically evaluate software development status and progress throughout the lifecycle. The software configuration audit is divided into two stages to determine if the developed software meets the requirements for the configuration items. First, the functional configuration audit verifies that the developed configuration items meet the software requirements. Also, it verifies that the results match the test criteria per configuration item. It is performed prior to or with the following physical configuration audit, PCA. At this point, it will evaluate documents such as software test plans, test design documents, and test reports. Second, it is the physical configuration audit. It is used for creating and accepting product baseline descriptions and developed software configuration items. It also reviews whether the development teams follow software code standardization guidelines. At this time, it reviews software specification, test document, source code, and so on. Let's look at some example questions during a configuration audit. First, has the configuration control board reviewed the changes? Second, has the additional change been made? Have you reviewed the changes through an informal technical review meeting? Have engineering standards been followed? Has the details of the change subject, date, author, and change been described? Has it been changed, recorded, reported according to the defined process? Are the relevant changes performed correctly? Through these questions, configuration audit is normally conducted. This time, let's look at the software configuration recording and reporting process, that is configuration status accounting. First, software configuration recording is an activity that provides traceability of each configuration item and their changes to identify software status. The main function is to create reports while managing the results and status of software configuration and change management on the database. There are roughly three categories of principles for configuration status accounting. First, important events about software development must be recorded. Second, all the events collected during the software development should be performed under complete database management. Third, complete reports on the software development process need to be created and distributed. According to these principles, the following items are recorded in the configuration record and report. For more information, please review the items on the screen. This time, let's discuss major software development configuration management tools. In software development, management of source code is one of the important points. We need a system that can store and manage the source code for various versions, change management, and collaboration. This is called version control system or source code management. Let's look at the main features of the SCM. First, the code for collaboration is shared. When several people collaborate, the code can be shared between the developers and the teams. Second, access control is possible. You can control the access based on the user's permission level. And it can manage various versions or configurations. The different code can be stored for each software development version or release. For example, they are code management for a released version or minor version, patch code management, and so on. It is also able to combine two or more of the various branches into a single code. Usually it's called merge. Source code management system can track a specific point in time. The most common tagging can be used to track a specific point in time. Next, it can track changes to each code. It should be able to keep track of how, whom, when your code has changed so that it can analyze the cause of the problem when a problem occurs. Let's continue to look at the flow of the software configuration management system. Initially, We performed local file system-based configuration management. We have run version updates using shared folder. Then a network-based client-server type management system was started for usage, and distributed management has become popular in recent years. The configuration management tools for each type are as follows. Folder sharing types include RCS, SCCS, and client-server types include Subversion, SVN, CVS, Perforce, Clearcase, TFS, and VSS. Types of distributed repository include Git, Mercurial, BitKeeper, SVK, and Darks. Among these tools, the classic product is CVS. Subversion led to the popularization of version management. Subversion is the most common tool so far, although it depends on the source. These two tools are a way to build a server and a user working on a client. The advantage of this architecture is that it is easy and simple to configure the system. But if you do not have a server, the problem arises that clients cannot work. It's very efficient when you work together in single site. But problem that you cannot update properly is often occurred when you collaborate with overseas labs, where the network are typically slow. Especially when the size of the source code is large, the problem becomes more serious. It is a tool of distributed repository type that appeared as a way to overcome this. When you check out from the server, the client will have all the same content as the server. That is, the client can be a server. If you build a copy of the server on your local machine, you can commit it yourself, or transfer only what you need to the server without connecting to the server. Typically, Git helps you build flexible systems by allowing you to easily build copies in local machine. Subversion is an open software version control system, abbreviated as SVN after the commands used in the command line interface. This was developed by CollabNet since 2000 to replace the limited CVS, and now it's being developed as a top-level Apache project with a worldwide developer community. Subversion follows the server-client model as shown on the screen. You can have the server on your computer or on a separate computer connected to the network. A centralized repository system, such as Subversion, is used by many clients to receive and use files from a central server. At this point, centralized repository stores the code in a single place of the repository server. When a developer receives, modifies, and saves the code, it is immediately reflected in the central repository, meaning that the server always has the master version of the source code. And if the server goes down or you do not have access to the network, of course you cannot commit the code or download the latest code. For that reason, if there is a problem with the central server's hard disk and you blow all the data, there is no way to recover it. In other words, the main disadvantage of Subversion is that the version control server must be in single place, so it depends entirely on the server's account. Distributed repository system, such as Git, replicate all the repositories without the client receiving the last snapshot. So if you have a server problem, you can restore the server with a clone of any client. That is, distributed repository is literally stored in multiple servers or multiple developer PCs. Each of them becomes a source code repository. The source code stored in each repository is not the same version of code, but different branch codes are stored. That is, each branch on a repository has a different version, and the places to access and import the source code are different. Therefore, there is no concept of a master version in the system itself. Let's take an example. A developer, Terry, is developing a database-related module by downloading code from server A. In addition, Michelle is developing UI-related modules on server B. Let's suppose they are committing to server A and server B from time to time as they develop their own system. Server A will have the most up-to-date version of database module part of the entire system, and Server B will contain the most up-to-date version of the UI module. After developing each module is completed, they can merge the codes of Server A and Server B to combine the development contents. That is, it is the architecture that the latest source code of the entire system is not explicitly stored in single specific place. If multiple versions of code are distributed across multiple repositories, there are some benefits. First, It is possible to develop by separating the repositories by team or functional unit, or separating the repositories by release version, so there is a lot of flexibility in source code version control. Second, because there is no concept of a centralized repository, even if a particular VCS system fails, you can continue to develop if only the VCS you are using has no problems. Also, you can also install VCS on your local PC to continue development without network connectivity. Third, even if the storage is damaged due to a server failure, it is easier to recover than the centralized server method because another server or PC stores both source code and their history.